Alright, so this video is going to be part 1 of our practice with finding equations for lines in 3 dimensions. Okay, so we want to find all 3 types of equations for the line that passes through the point 1, 2, 3 and is parallel to the vector 1, -1, 2. Okay, so in the last video we went over about how, first off, the equation of a line in 2 dimensions, it's y equals mx plus b, but I'm going to write it as b plus mx because it's easier to draw the comparison with the vector equation in 3 dimensions for a line. And that equation is that vector r equals vector r naught plus t times vector v. Okay, and just to kind of recap, well, I guess the first thing that we do is find the slope, right? If we find the slope, well, the slope is kind of the direction of this line, and that is going to be the same thing as vector v here. Okay, that's going to be the direction of this line. That's what vector v is doing. Okay, and when we plugged in a point, okay, after we found the slope, we plugged in a point. We plugged in, our whatever the x value was in for x, and we plugged in whatever the y value was for y, and we were able to find the y-intercept. Okay, so this is kind of like, you can kind of think of it as because we plugged in our initial point, this is the value that we got. Okay, and the kind of comparison here is that the initial point is the vector r naught. Okay, so these equations kind of make sense, and if you can draw that comparison, then you're good. Okay, now we need to actually start doing these equations. So first off, we need to find the vector equation. Okay, that's this equation, and we're going to find that pretty easily for this line. Okay, and why that is, well, they gave us the point, and they gave us a vector that's parallel to it. So they give us a point and a direction, and that's exactly what we need to set up our equations. Okay, now we're going to leave this as r. Okay, we leave this as r, and this is going to be equal to, well, r naught is that initial point. Okay, that initial point is 1, 2, 3. Okay, and it's not going to be, we're not just going to plug in the point 1, 2, 3. Okay, it's going to be a position vector. So it's a vector that points to this point. Okay, it's going to point to 1, 2, 3, and it starts at the origin. So we represent this as the vector 1, 2, 3. And this is going to be plus the parameter t times vector v is going to be that direction, right? It's kind of going to be like our slope in 2 dimensions, okay? And, well, if this line is parallel to this vector, okay, this vector is going in the same direction, so there you go, you have direction, and that vector is 1, -1, 2. Okay, and right there you have the vector equation of this line. Okay, now if you want to find the parametric equations, well, let's do that. Okay, we can, well, our r is the vector x, y, z, right? Just some random point when we plug in some t. All right, that's how we get it. We plug in some t and we get whatever point it is, or a position vector that points to some point on that line. Okay, that's actually what we're doing. So this is equal to 1, 2, 3 plus, we're going to just do a scalar multiplication here. We're going to put that t through this vector, and we get plus t, comma, -t, comma, 2t. All right, and that is going to basically just, after we do some vector addition here, we get our parametric equations. So x, y, z equals, doing that vector addition now, we have a 1 plus t, okay, because we have to add the x components, we add the y components, and we add the z components. So we get 1 plus t, comma 2 minus t, comma 3 plus 2t. Okay, and, well, the x component here is going to be equal to the x component here, right? The y component here will be equal to the y component here, and the z component here will be equal to the z component here. So now we get our parametric equations, and that is x equals 1 plus t, y equals 2 minus t, and z equals 3 plus 2t. Okay, there you go. Those are our parametric equations. And lastly, we need to find the symmetric equations. Okay, how do you find the symmetric equations? Well, you eliminate the parameter. Okay, you eliminate the parameter. So if we do that here, let's eliminate the parameter for, well, we have to just do it for all of them, but let's start out by solving for t. Okay, that's the first thing that we kind of have to do here. Well, if we have x equals 1 plus t, okay, that's one of our equations. We subtract 1 on both sides, and we get that t is equal to x minus 1. Okay, if we solve for t here, for this y equals 2 minus t, well, we get minus 2, and we got to divide by negative 1 on both sides, so we end up getting that t equals a negative y plus 2. Okay, and we have a z equals 3 plus 2t. Let's solve for t. We subtract 3 on both sides. Z minus 3 equals 2t. Divide by 2. We get that t equals z minus 3 over 2. Okay, so now we can set up our symmetric equations. Okay, if t equals all of these things, then all of these things are equal to each other. All right, so x minus 1 equals negative y plus 2 equals, actually, I'm going to draw this like this. There you go. Right in line with it. And then for our z, we have z minus 3 over 2. So now we have all three of our equations. We have the vector equation, the parametric equations, and the symmetric equations. Okay, so, you know, really, if you were just asked to solve for maybe a parametric equation, you want the parametric equations of this line, or maybe you just want the symmetric equations of this line, well, watch what happens here. Okay, we kind of talked about this in the last video. Look at this. For the number that's kind of being, the number that's not associated with t here, we have a 1, a 2, and a 3. Okay, we have a 1, 2, 3. That was our point. Okay, that was our initial point. And then we have the coefficients on t being 1, negative 1, and 2. Right there, that's our vector. That's our direction of this line. Okay, so you know, you can just set up parametric equations. Okay, I mean, that does take a little bit of repetition, and if you don't really have that down pat, you don't feel good with that, you can just start with the vector equation and then work your way to the parametric equations. Okay, the same thing with the symmetric equations. Okay, if you don't feel comfortable just, you know, kind of setting up a symmetric equation and that's it, well, then just go through the whole process, find the vector equation, that'll take you down to the parametric equations, and from that you can eliminate the parameter and get your symmetric equations. Okay, but what you got to realize about your symmetric equations, if you want to take that extra leap and just set up a symmetric equation right away, is that, well, here we have x minus 1. If you take out a negative here, we have y minus 2, and this is z minus 3. Okay, remember our original formula for the symmetric equations was x minus x naught, y minus y naught, and z minus z naught in the numerator. Okay, so you see you have a minus x naught. Your initial point is 1, 2, 3. Okay, so that's that x naught comma y naught comma z naught. Okay, that's your vector r naught. Okay, so that's where this initial point goes. Now what about our vector here? Well, like I said, if you take out this negative 1 and just let's shove it on the bottom. Okay, and we have a x minus 1. Let's put this over 1. The vector 1, negative 1, 2. The vector 1, negative 1, 2. Okay, so, you know, if you start to get the hang of this and you want to just try to jump for, you know, maybe the parametric equations or maybe the symmetric equations right away, if you're asked for one specifically, there you go. You know, you can kind of see what goes where. All right, so anyways, that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for vectors and the geometry of space, the explanation video for equations of lines in 3 dimensions, and the next video in the series. Lastly, if these videos are really helping you, consider supporting me on my Patreon, which I have linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.